magnetic field. Okay, so as the magnetic force on a charged particle is perpendicular to the velocity, it does not do any work on the particle, right? Work done by the magnetic force is zero. As the kinetic energy of the speed of the particle doesn't change due to the magnetic force, right? So when a charged particle Q is thrown in a magnetic field, let's say it is going in this direction and the magnetic field is in this direction. Let's say it is making an angle theta with the magnetic field, and the force can be given by F is equal to QEB sine theta, right? Yes or no? So depending on the initial condition, a charged particle can follow different paths. A charged particle can follow different paths, or we can say trajectories, okay, in a uniform magnetic field where the magnetic field is uniform. So let's take different cases when theta is 0, theta is 180 degree, okay, etc. And let's see how the trajectory it takes. So first case, when theta is 0 degree or 180 degree, that means particle is traveling in this direction and magnetic field is also in this direction. So in this case, what trajectory it is going to make, okay? First of all, the force would be on the charged particle 0, right? Because here it is 0 degree. Sine 0 or sine 180 is what? 0 degree. So particle will follow its original path in straight line. So the trajectory will be straight line. Now what if we project the particle at the angle 90 degree? That means the magnetic field is, let's say, in this direction. Let's take the magnetic field's direction into the page, okay? Into the page. And if the charged particle is going in this x direction, this is x direction, this is y direction, and into the page is the z direction. So basically it means that the angle between them is 90 degree, right? One is in x direction, one is in z direction. This angle is 90 degree. So force would be maximum, right? Yes or no?
Yes, sir.
So what will happen when the particle enters this uniform magnetic field? Okay, particle would want to go in a straight line, but since this force force will act on the particle, okay, first of all the force would be in y direction, right? Magnetic field is in this direction, z direction, velocity is in this direction. If you use the Fleming's what rule? Left hand rule, the force would be in
Left hand
positive
rule,
y
sir.
direction, right? सो ये फोर्स जो है मैग्नेटिक फोर्स अपनी तरफ पार्टिकल को खींचेगा, दैट मीन्स इस तरफ खींचेगा, राइट? सो इट विल ट्रैवल लाइक दिस वे. So basically it will follow a circular trajectory. What trajectory?
Circular trajectory.
So here the trajectory will be circular one. पार्टिकल को सीधी लाइन में ही जाना है. Okay, particle wants to go in this straight line in this x direction, but this magnetic field which is into the page, this is the magnetic field into the page. Okay, because of this magnetic field, force will act on this particle in this y direction, right? Because we know what is v cross b, it is in y direction. So particle will move in this y direction at each and every point. That's why it will make a circular trajectory. Okay,
Because
now
force is in the y direction.
yes,
Okay,
now
sir. So, sir, in simple terms, like since V and B, since what you say, V is traveling in like x direction,
yes,
then a force will be in y direction, and as a result, the particle will move in a since it move in a circular path.
yes.
Centripetal force is also there, right?
Hmm?
Centripetal force.
Yes, yes, it will provide centripetal force. Here one
So
question.
this why this force is providing centripetal force. Okay.
Yes, mv square upon I would be qvb.
Maybe.
Okay, here you can also find out the velocity. It would be qb upon m into r. This is qb upon m is
Yes.
nothing but omega. V is equal to r omega. Remember, this is known as cyclotron frequency. We will discuss this in an upcoming segment. Okay.
So cyclotron is not there.
Okay, don't worry, but I'm telling you that this is the cyclotron frequency.
Oh.
Now let's take final case, which is when the theta is 0 degree, 180 degree, and 90 degree. Sorry, other than these three. Okay.
Hmm.
When theta is other than 0, 180, 90 degree, then what would happen? Let's draw a diagram. This is this z direction. Now let's represent this axis as magnetic field. Okay, magnetic field is in x direction. Here the velocity is in y direction. Not velocity is not in y direction. Let's just call it y direction and z direction. Velocity is somewhat like this way. Okay, in this direction, in between y and x direction. Okay, particle is going in between direction. That means particle is neither going in x direction nor going in y direction. It is not also going in z direction. Okay, then what would happen? So you know that we can also always take components of this velocity, right? This one would be v cos theta, this one would be v sin theta. Yes or no?
Yes, sir.
This is the parallel component, this is the perpendicular component.
Yes.
So this v sin theta will provide the force to complete the circle. Okay, and this v cos theta will खींचेगा इस पार्टिकल को इस तरफ. So because of these two velocities,
Helical larger.
the trajectory will be helical. This trajectory will be helical. Okay.
Yes,
Here
sir.
the radius of helix would be mv square upon r is equal to q into v perpendicular into b. That means r can be given as mv perpendicular by qb. What is v perpendicular? V sin theta. mv sin theta upon qb.